Welcome. In this video I'd like to show you time and ground station access management in Aerospace Blockset for Xcos. The scenario is that we have three ground stations serving a single satellite, and we want to compute access times between those ground stations and this satellite. First thing that is necessary is to set simulation time. In Xcos, simulation always starts with time equals 0 and always ends with final integration time that is set by the user. This is, however, not very good for aerospace engineering, where not only time since the start of simulation is important, but very often the actual date has a very important role. To work with that, in Aerospace Blockset we have certain blocks that allow for time management. But we also have to set the simulation time, and let's assume that in this example the simulation time units we choose are minutes, and we want our simulation to last about 4 hours, which is 240 minutes. The second thing about the time is the refresh rate, the rate with which the simulation will be recalculated, the satellite propagation will be done. This will be set with a regular Xcos clock block, and we will set it to generate events every 1 minute from the first minute of the simulation. The most important part of the simulation is done by the J2 secular propagation block. We can use different propagation blocks, then they will be available in Aerospace Blockset, but almost all of them will have very similar inputs. This one has input of, the first input is a Keplerian argument input, which allows to input satellite initial position in a Keplerian reference frame. Second input allows to input epoch, so the time when those arguments were true. And for this simulation we will use 1st January 2010 at midnight, 0 hour 0 minute 0 seconds. This block allows for generating a modified Julian date since 1950 from a regular calendar date, which is very convenient for the user. And this particular block has its time multiplier set to 0, which means that its value will not change during the simulation. This is a clock that is stopped. And it's different for the second one. This is actually a main clock for our simulation that gives information about the time to all the other blocks, about the current time. So in this example we will set our initial time as 1st January 2010, but it's 3 o'clock in the morning, so it's not the epoch. The propagation block will have to calculate what are the values of Keplerian arguments 3 o'clock based on those values known at midnight. And time multiplier is set differently this time, because we want this clock to actually count time. This edit window, we can think about it as an edit window that answers a simple question. How many simulation units that we set in Xcos simulation parameters are in single day, in single 24-hour day? So we assume that we will be using minutes as our time base. So there are 24 times 60 minutes in 1 day. After the propagation is being done by the J2 secure propagation block, there are some time frame, reference frame conversions. This block converts from Keplerian to Cartesian frame. It gives position and velocity, and this block converts from the inertial frame to the frame that rotates together with the Earth. And it is worth noticing that this block also uses the modified Julian date since 1950, which is a time frame widely used in celeste life. Those three blocks are blocks that define ground stations. As an example, this block defines station 1, which is located minus 60 degrees latitude, minus 80 longitude. It's located 15 meters above the sea level, and it has mass of 5 degrees. What mass means is that if satellite is 5 degrees above the horizon or higher, it will be considered as visible by this ground station. So there are no obstacles on the horizon higher than 5 degrees on the horizon. Those three blocks are blocks that calculate if satellite is visible from a particular ground station. So each of them accepts a ground station description and a position of a satellite. Of course, in this simulation we have 3 ground stations and 1 satellite, but we could as well have multiple satellites simulated by multiple propagation blocks. Those station visibility blocks give 2 kinds of outputs. First one is a simple 0 or 1 output. 0 means the satellite is not visible, and 1 means it's visible. And the second output is event output. What it does, it generates events with the frequency equal to the frequency of the recalculation of the whole diagram set here. So in this example it would generate events every minute, but only when the satellite is visible. This may be useful for creating simulation when part of the diagram is only calculated when the satellite is visible. This is of course good for performance. So those 3 visibility variables are fed to plot visibility block, and there is also a 4th value that is sum of them. This block is a regular Xcos sum, and what it does, if any of the satellite is visible, if any of those outputs is equal to 1, then output of this block will also be greater than 0, therefore true. Plot visibility block also has another input, which is always located at the this is always the lowest of the inputs, and it accepts time. As you can see, time is not fed directly from the main simulation plot, but it goes through a time frame conversion block. Plot visibility block accepts different time frames, but in this example we would like to have calendar dates displayed in our simulation, in our plot, instead of Julian dates, which are kind of long and difficult to read. We will see that in the moment. Plot visibility block is also very simple. Its configuration consists of a value, 0,1 value, that says if it accepts inherited events or maybe it works on its own clock. Names of the ground stations. We can input any number of names. For example, if we input 1 name, there will be only 1 input for the ground station and 1 for the time. In this example we have 4 inputs, so there are 4 inputs for visibility events and 1 input for time, which is always time. And of course we can define the colors of the parts of the plot connected to each of the inputs. So let's now run the simulation. Okay, simulation is done, and we can see plot describing when satellites were visible by every ground station. And as you remember, our simulation started at 3 o'clock. Currently the block is only configured to show hour and minute, because showing dates would be difficult in this axis. Our simulation started at 3 o'clock and lasted for 4 hours, so until 7 o'clock, and the satellite was actually visible for our ground station for some periods of time. And we can see that ground station 2 and 3 are actually located quite closely to themselves. So we can see that ground station number 2 saw the satellite first at 3:37, then while it was still visible, ground station number 3 saw it, and ground station number 1 saw it at a completely different time because it's located in the southern hemisphere. And that concludes this presentation. Thank you very much.